Doing regression with multiple variables in Microsoft Excel. Here we have a spreadsheet for an ice cream store. It shows the number of gallons of ice cream they sold in a month, the price they were charging per cup of ice cream, the price their nearest competitor was charging, the average temperature for that month, the amount that they spent for advertising during that month, the number of sales people they had on average, and the gallons that were sold at the downtown store that month. And they want to know what is related to the number of gallons that they sell. So we're going to do regression. We go to Data, Data Analysis, select Regression. Our Y input range is our gallons sold. Our X input range, on the other hand, is everything else. And we're going to put our results into a new worksheet and click OK. And then when we look at our results, we can see that with an R squared of 92.6%, this is a really tight regression. However, when we look at our p-values, we can see that there are a number of values that don't really seem that related. In fact, our intercept at 63%, with a p-value of 63%, means that there's a 63% chance that this 3.33 that we're using for the intercept has nothing to do with our final price. The other ones that seem questionable are advertising a number of salesmen and gallons sold at downtown store. All of those seem to have at least a possibility of being irrelevant to our eventual price. Number of salesmen we actually might want to work with because it's close. There's just a 17% chance it has nothing to do with it. Advertising and gallons sold at the downtown store have slighter rates of being irrelevant to it. So let's go ahead and do our regression again and take all of this into effect. So we're going to get rid of our intercept, our constant, and we're going to eliminate advertising, number of salesmen, and gallons sold at the downtown store from the mix. Okay? So we're going to do another regression, and this time we are going to just do, our output stays the same, but for our input we're just going to use price, competitor price, and temperature. Well, just for the sake of argument, let's use advertising a number of salesmen as well. But we're definitely going to leave gallons sold at the downtown store at 35%. I think it's safe. And since they really didn't like our intercept, we're going to set the constant to 0 and click OK. Now, our R squared is 99%, which is even better. If we look at the p-values for the things that are set, we still have extremely good p-values for price, competitor price, and temperature. There's a 25% chance that advertising has nothing to do with our final output, and a 15% chance that the number of salesmen has nothing to do with our output. But I'm willing to accept that. So our equation for this would be y equals 0, because our intercept is 0, plus negative 27 times the price, plus negative 27 times the price, which is the same as saying minus 27 times the price, plus 11.4 times the competitor price, plus 0.479 times the temperature, minus 0.0014 times the advertising, minus 0.218 times number of salesmen.